Welcome to WebLizard Lab's Cert Lab. This is SC-500 practice questions, Azure Network Security. You will work through 36 questions covering network roles, security admin rules, firewalls, private endpoints, virtual networks, secure connectivity, and network diagnostics. Listen for the traffic path, trust boundary, policy layer, and evidence source that decides each answer. You will hear each complete scenario and every answer choice. Multi-select questions state how many answers to select. Matching and ordering questions keep the full workspace visible. After the cue, lock in your answer. You will have 3 seconds before the answer appears. Pause whenever you want additional thinking time. Question 1. An administrator must manage network security groups, security rules, and application security groups in an Azure subscription. Which built-in role should you assign? Select one answer. Choice A, Reader. Choice B, Virtual Machine Contributor. Choice C, Network Contributor. Choice D, Security Reader. Lock in your answer. The correct answer is C, Network Contributor. Microsoft documents Network Contributor as the built-in role for managing NSGs, security rules, and ASGs. An appropriately permissioned custom role is also possible, but the question specifically asks for a built-in role. Question 2. Production virtual networks are members of the Production Network Group in Azure Virtual Network Manager. A central network team has defined a security admin rule that blocks inbound SSH and needs to enforce it across the group. Which sequence should the team use? Select one answer. Choice A, associate the security admin configuration with the production network group and then deploy the configuration. Choice B, associate the rule collection with the production network group and then deploy a connectivity configuration. Choice C, associate each security admin rule with the production network group and then deploy the rule collection. Choice D, associate the rule collection with the production network group and then deploy the security admin configuration. Lock in your answer. The correct answer is D. Associate the rule collection with the production network group and then deploy the security admin configuration. Azure Virtual Network Manager targets security admin policy by associating the rule collection with the required network group. The rules take effect on virtual networks in that group when the security admin configuration is deployed. Question 3. A retailer is building regional hubs in one standard Azure Virtual WAN. The security team wants native traffic governance and routing policies managed centrally by Azure Firewall Manager. Which hub design should the retailer use? Select one answer. Choice A, add connectivity-only virtual hubs and govern each spoke with its own route table design. Choice B, use Azure Firewall Manager to add secured virtual hubs to the existing virtual WAN. Choice C, use basic virtual hubs and attach Azure Firewall to each hub. Choice D, deploy firewalls beside standard hubs without associating Firewall Manager security and routing policies. Lock in your answer. The correct answer is B. Use Azure Firewall Manager to add secured virtual hubs to the existing virtual WAN. A secured virtual hub is an Azure Virtual WAN hub with security and routing policies configured by Azure Firewall Manager, and multiple secured hubs can exist in the same virtual WAN. Therefore, option B directly meets the centralized native governance requirement. Question 4. A network team is creating a custom IPsec/IKE policy for a new site-to-site connection. The VPN device vendor has supplied one supported combination of main mode and quick mode parameters. What should the team configure in Azure? Select one answer. Choice A, configure only the main mode parameters and inherit the quick mode defaults. Choice B, apply every required IKE and IPsec parameter as one policy, using values accepted by the peer device. Choice C. Configure 2 custom combinations on the connection, so either peer proposal can succeed. Choice D. Configure a complete Azure combination and allow the on-premises device to retain a different combination. Lock in your answer. The correct answer is B. Apply every required IKE and IPsec parameter as one policy, using values accepted by the peer device. Azure permits one custom IPsec IKE policy combination on a connection. The team must specify the complete IKE and IPsec parameter set and ensure that the on-premises peer supports that combination. Question 5. An ERP application and a laboratory application are hosted in 2 isolated private networks. A Windows server in each network can reach only its local application backend, and both servers can establish outbound connections to global secure access. You must publish each application through Microsoft Entra Private Access. Which connector design should you use? Select one answer. Choice A. Install a connector on each Windows server. Place the connectors in separate connector groups and associate each application with the group that can reach its backend. Choice B. Install a connector on each Windows server. Place both connectors in one shared connector group and associate both applications with that group. Choice C. Install a connector on each Windows server. Place the connectors in separate connector groups and associate both applications with the group in the ERP network. Choice D. Install a connector on each Windows server. Place the connectors in separate connector groups and associate each application with the group in the other application's network. Lock in your answer. The correct answer is A. Install a connector on each Windows server, place the connectors in separate connector groups, and associate each application with the group that can reach its backend. A is correct. A connector must run on Windows Server infrastructure that can reach the backend resource. Connector groups can handle traffic for specific applications, so separate groups preserve the 2 networks' reachability boundary. Question 6. An analytics application in VNet 1 must connect privately to an Azure SQL database through an address allocated from VNet 1. Which configuration should the network team deploy? Select one answer. Choice A. Create a private endpoint in a VNet 1 subnet and target the intended Azure SQL private link resource. Choice B. Create only a DNS record for the Azure SQL name and leave the service on its public endpoint. Choice C. Enable a Microsoft.sel service endpoint on the VNet 1 subnet and add a virtual network rule for the Azure SQL logical server. Choice D. Create a private endpoint in a VNet 1 subnet for the intended Azure SQL resource and begin using it while its private endpoint connection status is pending. Lock in your answer. The correct answer is A. Create a private endpoint in a VNet 1 subnet and target the intended Azure SQL private link resource. A private endpoint is a network interface that receives a private IP address from the virtual network and connects to the selected private link-powered service. Creating it in VNet 1 and binding it to the intended Azure SQL target satisfies both requirements. Question 7. A provider wants to expose an application through an Azure Private Link service using the generally available load balancer-backed design. Which existing load balancer configuration can the provider use? Select one answer. Choice A, a basic load balancer, whose backend pool is configured by network interface. Choice B, a basic load balancer, whose backend pool is configured by IP address. Choice C, a standard load balancer, whose backend pool is configured by IP address. Choice D, a standard load balancer, whose backend pool is configured by network interface. Lock in your answer. The correct answer is D, a standard load balancer whose backend pool is configured by network interface. The generally available private link service topology is supported on a standard load balancer whose backend pool is configured by network interface. Basic load balancer and IP address configured backend pools are not supported for this topology. Question 8. A regulated workload must send outbound HTTPS traffic through Azure Firewall. The firewall must decrypt and inspect the TLS traffic, evaluate full URL paths, and apply a fully managed intrusion detection and prevention system. Which design uses the minimum Azure Firewall SKU that provides all three capabilities? Select one answer. Choice A, Azure Firewall Basic with Threat Intelligence in Alert Mode. Choice B, Azure Firewall Standard with DNS Proxy and Threat Intelligence in Alert and Deny Mode. Choice C, Azure Firewall Premium with TLS inspection and IDPS enabled. Choice D, Azure Firewall Standard with application FQDN rules and web categories. Lock in your answer. The correct answer is C, Azure Firewall Premium with TLS inspection and IDPS enabled. C is correct. Azure Firewall Premium adds TLS inspection, full URL filtering when TLS inspection is enabled, and fully managed IDPS. Standard does not support TLS inspection, IDPS, or URL filtering, and Basic provides neither the required inspection nor prevention capabilities. Question 9. A security team is performing a quarterly compliance audit of an Azure VM. The team needs one view of the aggregated inbound and outbound security and admin rules applied to the VM network interface. No individual packet flow needs to be simulated. What should the team use? Select one answer. Choice A, run NSG diagnostics for one representative source to destination flow. Choice B, open effective security rules for the Web01 network interface. Choice C, run IP flow verify for one inbound TCP tuple. Choice D, review only the rules configured in the subnet network security group. Lock in your answer. The correct answer is B, open effective security rules for the Web01 network interface. Effective Security Rules is the Network Watcher view designed to show the aggregated inbound and outbound security and admin rules applied to a network interface, which matches an audit requirement without a flow simulation. Question 10. An NSG allows a workload VM to initiate outbound HTTPS connections to a partner service. Existing inbound rules deny new connections initiated from the partner's source addresses. The partner's response traffic must return over the established connection. How should you configure the NSG? Select one answer. Choice A, keep the outbound allow rule. Do not add an inbound response rule. New inbound connections remain subject to inbound rules. Choice B, add an inbound allow rule for the partner on TCP 443. Because every outbound allow rule requires an opposite direction response rule. Choice C, replace the outbound allow rule with an inbound allow rule, because HTTPS responses are evaluated as newly initiated inbound connections. Choice D, add matching inbound and outbound allow rules with the same priority, so that the two rules share one flow record. Lock in your answer. The correct answer is A, keep the outbound allow rule. Do not add an inbound response rule. New inbound connections remain subject to inbound rules. NSGs are stateful. An allowed outbound connection creates flow state that permits the response without a separate inbound response rule. A connection initiated externally is a different flow and still needs to satisfy an inbound rule, which preserves the scenario's restriction. Question 11. A central network team uses Azure Virtual Network Manager to govern HTTPS traffic in targeted virtual networks. The central policy should permit the traffic, but each workload team must still be able to deny it with an NSG. Which security admin rule action should the central team configure? Select one answer. Choice A, always allow. Choice B, allow. Choice C, deny. Choice D, remove the workload NSGs. Lock in your answer. The correct answer is B, allow. Allow is evaluated before the NSG and then continues to NSG evaluation, so workload teams retain the ability to deny the traffic. Always allow would bypass later NSG evaluation. Question 12. An insurance company uses a secured virtual hub to filter traffic between connected virtual networks. An engineer proposes adding a UDR to every spoke, solely to steer that traffic through the hub firewall. Which design should the company use? Select one answer. Choice A, use the secured virtual hub automated routing and omit those per-spoke firewall UDRs. Choice B, add a firewall UDR to every spoke before allowing any filtered traffic. Choice C, add a customer-managed UDR to the virtual hub for each connected spoke. Choice D, remove the firewall manager routing policies and rely only on spoke UDRs. Lock in your answer. The correct answer is A. Use the secured virtual hub automated routing and omit those per-spoke firewall UDRs. A secured virtual hub provides automated routing for filtered flows, so customers do not need to create their own UDRs merely to route traffic through the firewall. Option A follows that operating model. Question 13. An existing site-to-site VPN connection uses an approved custom IPsec/IKE policy. The tunnel stopped after the on-premises administrator changed only the peer's IKE integrity algorithm. Change control prohibits modifying the Azure policy. What should the Azure administrator recommend? Select one answer. Choice A. Change the Azure connection to point to site so that the branch device no longer participates in policy negotiation. Choice B. Enable policy-based traffic selectors on the Azure connection so it accepts the peer's new integrity algorithm. Choice C. Restore the peer's IKE integrity algorithm to match the value specified in the Azure connection policy. Choice D. Delete the IPsec integrity setting from the peer so the device negotiates an Azure default. Lock in your answer. The correct answer is C. Restore the peer's IKE integrity algorithm to match the value specified in the Azure connection policy. The on-premises VPN device configuration must match or contain the algorithms and parameters specified in the Azure IPsec IKE policy, including the IKE integrity algorithm. Because change control prohibits modifying the approved Azure policy, the peer's changed IKE integrity value should be restored to match it. Question 14. A company wants its primary set of internal FQDNs and IP ranges to be tunneled for the assigned remote workforce. A payroll portal within that estate must be available only to the payroll team and must use a different conditional access policy. Which design uses the documented roles of the two Microsoft Entra Private Access models? Select one answer. Choice A. Place the primary resource set in quick access and place the payroll portal in a per-app global secure access application. Choice B. Place the entire estate only in quick access and apply the payroll policy to the connector group. Choice C. Place the primary resource set in a per-app application and place only the payroll portal in quick access. Choice D. Place the entire estate and payroll portal in one per-app application with one shared access policy. Lock in your answer. The correct answer is A. Place the primary resource set in quick access and place the payroll portal in a per-app global secure access application. A is correct. Quick access is the primary group of private FQDNs and IP addresses. A global secure access per-app application provides granular control for a subset that needs distinct users or conditional access policies. Question 15. A vendor team can create resources in its virtual network, but does not own and lacks the required Azure RBAC permissions on a customer-owned private link resource. Which connection workflow should the vendor use? Select one answer. Choice A. Choose automatic approval and expect the connection to be approved immediately. Choice B. Create a manual request and begin sending traffic while its state is pending. Choice C. Create a manual request and wait for the private link resource owner to approve it. Choice D. Configure private DNS and treat DNS resolution as approval of the connection. Lock in your answer. The correct answer is C. Create a manual request and wait for the private link resource owner to approve it. Automatic approval is for a caller that owns or has the required permissions on the private link resource. Without those permissions, the vendor should manually request the connection and wait for the resource owner to approve it. Question 16. A service provider publishes a payment API through Azure Private Link Service. A standard load balancer has front-end IP configuration FE payments and back-end pool pay app pool. Subnet PLS NAT is reserved for private link service NAT addresses. The design review must identify both the load balancer object the private link service references to receive traffic and the source addresses that the provider will observe for consumer traffic. Which design is correct? Select the best answer. Choice A. Reference FE payments, choose PLS NAT for NAT addresses, and observe consumer traffic as originating from the PLS NAT pool. Choice B. Reference Pay App Pool, choose PLS NAT for NAT addresses, and observe consumer traffic as originating from the PLS NAT pool. Choice C. Reference FE payments, omit a NAT address subnet, and observe each consumer private endpoint address as the provider-side source. Choice D. Reference PLS NAT as the receiving frontend, choose the FE payment subnet for NAT addresses, and observe sources from that frontend subnet. Lock in your answer. The correct answer is A. Reference FE payments, choose PLS NAT for NAT addresses, and observe consumer traffic as originating from the PLS NAT pool. A private link service references the standard load balancer front-end IP configuration at which it receives traffic. It also uses a selected subnet as its NAT IP pool, and all consumer traffic appears to the service provider to originate from that pool. FE payments and PLS NAT therefore have distinct documented roles. Question 17. Azure Firewall allows an on-premises client to initiate a TCP connection to a server in an Azure Virtual Network. An explicit deny rule blocks connections initiated from the Azure Virtual Network to on-premises. Which two traffic outcomes should you expect? Select 2. Select all answers that apply. Choice A. Return packets for the established on-premises initiated connection are allowed. Choice B. A new connection initiated by the Azure server toward on-premises is blocked. Choice C. Return packets for the established connection are blocked by the reverse direction deny rule. Choice D. Any new Azure to on-premises connection is allowed because an on-premises to Azure session exists. Lock in your answer. The correct answers are A and B. A. Return packets for the established on-premises initiated connection are allowed. B. A new connection initiated by the Azure server toward on-premises is blocked. A and B are correct. Azure Firewall is stateful, so it permits return traffic belonging to an established TCP or UDP connection. The explicit reverse direction deny still blocks a separately initiated new connection from Azure to on-premises. Question 18. A checkout service runs on an Azure Virtual Machine scale set. An engineer must simulate a specified source-to-destination flow for a scale-set network interface and obtain the allow or deny result with rule details. Which action should the engineer take? Select one answer. Choice A. Open effective security rules and treat the aggregate list as a simulated verdict. Choice B. Run IP flow verify directly against a scale-set network interface. Choice C. Use NSG diagnostics with the required source and destination. Choice D. Run NSG diagnostics for only the containing subnet without selecting the scale-set network interface. Lock in your answer. The correct answer is C. Use NSG diagnostics with the required source and destination. NSG diagnostics supports virtual machine scale-set network interfaces and simulates a specified source-to-destination flow, returning the verdict and responsible rule details. You have completed 18 questions. Take a moment to reset your attention. In the remaining questions, keep separating packet filtering from private service access, centralized policy from per-resource controls, connectivity from inspection, and prevention from diagnostics. Question 19. Match each proposed application security group configuration to its support status. Each ASG already contains the first network interface named in the proposal. Match each target to the correct option. Items to match. T1. ASG Web contains NIC Web 1 in VNet 1. Add NIC Web 2 from VNet 1 to ASG Web. T2. ASG Data contains NIC Data 1 in VNet 1. Add NIC Data 2 from VNet 2 to ASG Data. T3. Create an NSG rule with ASG Web from VNet 1 as source and ASG API from VNet 1 as destination. T4. Create an NSG rule with ASG Web from VNet 1 as source and ASG API from VNet 2 as destination. Available choices. Choice supported, supported. Choice unsupported, unsupported. Lock in your answer. The correct matches are ASG Web contains NIC Web 1 in VNet 1. Add NIC Web 2 from VNet 1 to ASG Web. Choice supported, supported. ASG Data contains NIC Data 1 in VNet 1. Add NIC Data 2 from VNet 2 to ASG Data. Choice unsupported, unsupported. Create an NSG rule with ASG Web from VNet 1 as source and ASG API from VNet 1 as destination. Choice supported, supported. Create an NSG rule with ASG Web from VNet 1 as source and ASG API from VNet 2 as destination. Choice unsupported, unsupported. All network interfaces in one ASG must be in the virtual network established by the first interface, so A is supported and B is unsupported. When an NSG rule names both source and destination ASGs, the interfaces in both groups must be in the same virtual network, so C is supported and D is unsupported. Question 20. Match each central governance requirement to the Azure Virtual Network Manager security admin rule action. Each action can be used once. One candidate is unused. Match each target to the correct option. Items to match. T1. Permit a flow, but let workload NSGs still deny it. T2. Permit a flow even when a workload NSG contains a conflicting deny. T3. Block a flow centrally before workload NSGs are evaluated. Available choices. Choice A. Security admin rule action, allow. Choice B. Security admin rule action, deny. Choice C. Security admin rule action, always allow. Choice D. Network security group rule action, allow. Lock in your answer. The correct matches are permit a flow, but let workload NSGs still deny it. Choice A. Security admin rule action, allow. Permit a flow even when a workload NSG contains a conflicting deny. Choice C, security admin rule action, always allow. Block a flow centrally before workload NSGs are evaluated. Choice B, security admin rule action, deny. Allow continues to NSG evaluation. Always allow permits the traffic and terminates later NSG evaluation. And deny blocks the traffic and terminates evaluation. An NSG allow is a lower layer action, not a security admin rule action. Question 21. A construction company uses a basic Azure Virtual WAN and a basic hub only for site-to-site VPN connections from temporary offices. The company now must centrally inspect traffic from those offices to connected Azure virtual networks by using Azure Firewall in a secured virtual hub. Which minimum change should the network team make? Select one answer. Choice A. Keep the basic virtual WAN and basic hub and deploy Azure Firewall directly in the basic hub. Choice B. Keep the basic virtual WAN and use Firewall Manager to convert the basic hub to a secured virtual hub with Azure Firewall. Choice C. Upgrade the virtual WAN from basic to standard and then use Firewall Manager to convert the existing hub to a secured virtual hub with Azure Firewall. Choice D. Upgrade the virtual WAN to standard. Deploy Azure Firewall in a connected spoke virtual network and rely on the hub default routes to send branch traffic through it. Lock in your answer. The correct answer is C. Upgrade the virtual WAN from basic to standard, and then use Firewall Manager to convert the existing hub to a secured virtual hub with Azure Firewall. A basic virtual WAN with a basic hub supports site-to-site VPN only. Azure Firewall is available with standard virtual WAN. After the upgrade, Firewall Manager can convert the existing hub to a secured virtual hub, whose security and routing policies can govern and filter branch to VNet traffic. Question 22. A company must connect two workloads to an Azure virtual network. A branch office sends traffic through its on-premises VPN device. A traveling auditor connects from an individual laptop. Which two connection types should the company use? Select two. Select all answers that apply. Choice A. Use a site-to-site connection for the branch office. Choice B. Use a point-to-site connection for the branch office. Choice C. Use a site-to-site connection for the traveling auditor. Choice D. Use a point-to-site connection for the traveling auditor. Lock in your answer. The correct answers are A and D. A. Use a site-to-site connection for the branch office. D. Use a point-to-site connection for the traveling auditor. A site-to-site connection creates the IPsec/IKE tunnel between Azure VPN Gateway and the branch VPN device. A point-to-site connection is intended for an individual remote client, such as the auditor's laptop. Question 23. A private network allows outbound connections, but does not accept unsolicited inbound internet connections. You are preparing a Microsoft Entra Private Access connector deployment. Which two actions align with the connector's documented placement and connection model? Select two. Select all answers that apply. Choice A. Install the connector on a supported Windows server that can reach the private application backends. Choice B. Permit the connector server to establish outbound connections to the Global Secure Access Service. Choice C. Expose an inbound listener on the connector server for connections initiated by Global Secure Access. Choice D. Install the connector on a Linux jump host because it can reach the private application backends. Lock in your answer. The correct answers are A and B. A. Install the connector on a supported Windows server that can reach the private application backends. B. Permit the connector server to establish outbound connections to the Global Secure Access Service. A and B are correct. The private network connector runs on Windows Server infrastructure with access to the backend resources and facilitates outbound connections to global secure access. Question 24. A private endpoint is approved and has a private IP address. An application continues to use the service FQDN, but DNS resolves that name to the public endpoint. Which change directs the application to the private endpoint? Select one answer. Choice A. Recreate the private endpoint network interface without changing DNS. Choice B. Change the connection from automatic approval to manual approval. Choice C. Disable public network access while leaving the FQDN mapped to the public endpoint. Choice D. Configure DNS so the service FQDN resolves to the private endpoint IP address. Lock in your answer. The correct answer is D. Configure DNS so the service FQDN resolves to the private endpoint IP address. Applications that use the service FQDN must resolve that name to the private endpoint IP address. Option D corrects the faulty control plane identified in the scenario, DNS resolution. Question 25. A provider application receives traffic through a private link service. Its logs show a provider-allocated private address as the source instead of the original consumer address. What explains this observation? Select one answer. Choice A. The standard load balancer's outbound SNAT rule translates incoming consumer addresses to an address from its front-end configuration. Choice B. The standard load balancer front-end address is always copied into the packet's source field. Choice C. Private link service performs provider-side NAT, so the allocated NAT IP appears as the source. Choice D. The private endpoint connection maps each consumer to an address selected from the provider subnet before packets reach the service. Lock in your answer. The correct answer is C. Private link service performs provider-side NAT, so the allocated NAT IP appears as the source. Private link service performs NAT on traffic from private endpoints. On the provider side, the allocated NAT IP appears as the source address instead of the consumer's actual source IP. Question 26. An Azure Firewall policy has two network rule collections in the same rule collection group that both match SSH traffic from a management subnet. The deny collection has priority 200, and the allow collection has priority 400. No threat intelligence rule blocks the flow. Which two statements describe the evaluation? Select two, select all answers that apply. Choice A. The deny collection is evaluated before the allow collection because 200 is the higher priority. Choice B. The allow collection is evaluated first because allow actions take precedence over deny actions. Choice C. Processing stops when the matching deny rule is found. Choice D. Evaluation continues to the allow collection after the deny match because both collections contain network rules. Lock in your answer. The correct answers are A and C. A. The deny collection is evaluated before the allow collection because 200 is the higher priority. C. Processing stops when the matching deny rule is found. A and C are correct. Within the same rule type, lower numeric values represent higher priority, so priority 200 is evaluated before 400. Azure Firewall rules are terminating, so the first matching deny ends processing for the flow. Question 27. An administrator must test an outbound TCP 443 flow from a specific Azure VM network interface and identify the rule responsible for the result. Which two statements describe the appropriate IP flow verify test? Select two, select all answers that apply. Choice A. Provide protocol plus local and remote IP addresses and ports. Let IP flow verify infer direction from the endpoint roles. Choice B. Provide traffic direction, protocol, local and remote IP addresses, and local and remote ports to IP flow verify. Choice C. Expect the effective inbound and outbound security rule lists for the network interface, ordered by processing priority. Choice D. Expect access allowed or access denied together with the matching rule information. Lock in your answer. The correct answers are B and D. B. Provide traffic direction, protocol, local and remote IP addresses, and local and remote ports to IP flow verify. D. Expect access allowed or access denied together with the matching rule information. IP flow verify accepts the direction, protocol, local and remote addresses, and local and remote ports for a VM NIC flow. It returns access allowed or access denied and identifies the rule responsible for the result. Question 28. An NSG processes lower numeric priority values first and stops processing when traffic first matches a rule. For this evaluation, the Internet client's source IP is not included in the Virtual Network Service tag. The client sends TCP traffic to port 443 on a VM. The inbound rules are: Priority 100 denies Internet TCP 22. Priority 200 denies Virtual Network TCP 443. Priority 300 allows Internet TCP 443. And Priority 400 denies Internet TCP 443. Build the NSG decision path in the exact order it occurs. Arrange the options in the correct order. Available steps. Choice A. Stop processing. The Priority 400 deny rule is not evaluated. Choice B. Evaluate Priority 300. It matches and allows the traffic. Choice C. Evaluate Priority 100. It does not match because the destination port is 443. Choice D. Evaluate Priority 200. It does not match because the client's source IP is not included in the Virtual Network Service tag. Lock in your answer. The correct order is: first, choice C, evaluate Priority 100. It does not match because the destination port is 443. Second, choice D, evaluate Priority 200. It does not match because the client's source IP is not included in the Virtual Network Service tag. Third, choice B, evaluate Priority 300. It matches and allows the traffic. Fourth, choice A, stop processing. The Priority 400 deny rule is not evaluated. The NSG starts at Priority 100 because lower numeric values are processed first. Priority 100 does not match TCP 443. Priority 200 does not match because the scenario states that the client's source IP is not included in the Virtual Network Service tag. Priority 300 is the first matching rule and allows the flow. Processing then stops, so Priority 400 is not evaluated. Question 29. A company must retain centralized Azure Virtual Network Manager security admin rule enforcement in East US. It already has one security admin configuration deployed to East US. Finance and engineering virtual networks are in separate network groups there, and security operations must manage the two rule sets independently within Azure Virtual Network Manager. Which design satisfies the regional configuration limit? Select one answer. Choice A. Create separate finance and engineering security admin configurations in East US and associate each configuration with its network group. Choice B. Create separate finance and engineering connectivity configurations in East US and place the security rules in those configurations. Choice C. Create separate finance and engineering rule collections in the existing security admin configuration and associate each collection with its network group. Choice D. Create separate finance and engineering NSGs for every subnet in East US and remove the existing security admin configuration. Lock in your answer. The correct answer is C. Create separate finance and engineering rule collections in the existing security admin configuration and associate each collection with its network group. Only one security admin configuration can be deployed to a region. Multiple policy sets in that region should be represented by multiple rule collections inside that security admin configuration, with each collection associated to the intended network group. Question 30. A manufacturer has two secured virtual hubs in one Azure Virtual WAN. Azure Firewall and Firewall Manager policies are already configured. The company must secure branch-to-branch traffic both within one hub and between the two hubs. Which additional configuration is required? Select one answer. Choice A. Create a custom UDR on every branch connection that points to the firewall. Choice B. Move each secured hub into a separate virtual WAN resource. Choice C. Replace the secured hubs with basic virtual hubs. Choice D. Configure Azure Virtual WAN routing intent for the protected traffic paths. Lock in your answer. The correct answer is D. Configure Azure Virtual WAN routing intent for the protected traffic paths. Azure Virtual WAN routing intent must be configured to secure inter-hub and branch-to-branch communications, including branch-to-branch communication within a single hub. Existing firewalls and policies do not remove this requirement. Question 31. A company is designing a point-to-site VPN that uses Microsoft Entra ID authentication. The design must use one VPN gateway and one audience value. Which gateway design satisfies the documented constraints? Select one answer. Choice A. A basic SKU, a non-policy-based VPN type, and one audience value. Choice B. A compatible non-basic SKU, a policy-based VPN type, and one audience value. Choice C. A compatible non-basic SKU, a non-policy-based VPN type, and one audience value. Choice D. A compatible non-basic SKU, a non-policy-based VPN type, and two audience values. Lock in your answer. The correct answer is C. A compatible non-basic SKU, a non-policy-based VPN type, and one audience value. Microsoft Entra Authenticated Point-to-Site VPN is incompatible with the basic SKU and with a policy-based VPN type. A point-to-site VPN gateway also supports only one audience value at a time, so only option C satisfies all three constraints. Question 32. Quick Access contains 10.44.0.0/16 on TCP 3389 for all engineers and uses a baseline conditional access policy. A security architect creates a global secure access enterprise application for 10.44.5.20 on TCP 3389 so that only Tier 3 administrators are subject to a stricter conditional access policy. The overlapping segment is retained during the migration. Which two facts must the architect account for? Select two, select all answers that apply. Choice A. The enterprise application segment takes priority for 10.44.5.20 on TCP 3389. Choice B. Tier 3 administrators must be assigned to the enterprise application for that segment. Choice C. Quick Access processes non-assigned users for that endpoint because its /16 segment is broader. Choice D. The Quick Access user assignments transfer automatically to the new enterprise application. Lock in your answer. The correct answers are A and B. A. The enterprise application segment takes priority for 10.44.5.20 on TCP 3389. B. Tier 3 administrators must be assigned to the enterprise application for that segment. A and B are correct. For an allowed overlap between quick access and a private access enterprise application, the enterprise application segment has priority. Traffic to that segment is evaluated by the enterprise application configuration, including its assignments and conditional access policies. So the intended Tier 3 population must be assigned there. Question 33. A media workflow already uses an Azure Storage private endpoint that targets the blob subresource. The workflow must now access both blob data and an Azure file share privately. Which two actions should the team take? Select two. Select all answers that apply. Choice A. Retarget the existing private endpoint from blob to file. Choice B. Keep the existing private endpoint targeted to blob. Choice C. Use the blob-targeted private endpoint for file traffic without another target. Choice D. Create a second private endpoint targeted to the file subresource. Lock in your answer. The correct answers are B and D. B. Keep the existing private endpoint targeted to blob. D. Create a second private endpoint targeted to the file subresource. Private endpoint protection is scoped to the specified target subresource. Azure Storage blob and file access require separate private endpoints with corresponding targets, so the existing blob endpoint should remain, and a second file-targeted endpoint should be created. Question 34. A private link service uses a pool of provider NAT addresses, so connections from several private endpoints can appear under the same source address in application logs. The application needs connection metadata that can distinguish the originating consumers. What should the provider enable? Select one answer. Choice A. TCP proxy v2 on the private link service, and header parsing on the back-end application. Choice B. Additional NAT IP configurations, with the backend treating each observed NAT IP as one consumer. Choice C. Standard load balancer floating IP, with the backend treating the front-end IP as the consumer identifier. Choice D. A separate private link service alias for each customer, with the backend reading the alias from each connection. Lock in your answer. The correct answer is A. TCP proxy v2 on the private link service, and header parsing on the backend application. The documented control is proxy protocol on the service. Its header carries the consumer's actual source IP address and the private endpoint link ID, which the backend application can combine to identify consumers even when provider NAT addresses are shared. Therefore, option A is the only option that supplies the required backend readable consumer connection metadata. Question 35. A child Azure Firewall policy inherits a parent policy. Assume threat intelligence does not block the flow, and the flow matches no rule. So evaluation continues through every listed collection. Arrange the 4 rule collections in the order in which Azure Firewall evaluates them, from first to last. Use each label once. Arrange the options in the correct order. Available steps. Choice A. Parent policy. Application rule collection in a parent rule collection group with priority 200. Choice B. Child policy. Network rule collection in a child rule collection group with priority 100. Choice C. Child policy. DNAT rule collection in a child rule collection group with priority 600. Choice D. Parent policy. Network rule collection in a parent rule collection group with priority 400. Lock in your answer. The correct order is, first, choice C, child policy, DNAT rule collection in a child rule collection group with priority 600. Second, choice D, parent policy, network rule collection in a parent rule collection group with priority 400. Third, choice B, child policy, network rule collection in a child rule collection group with priority 100. Fourth, choice A, parent policy, application rule collection in a parent rule collection group with priority 200. The exact order is CDBA. Azure Firewall makes a DNAT pass before network and application passes, regardless of group priority or policy inheritance. Within the network pass, parent policy rule collection groups precede child policy groups, even though the child group has a lower numeric priority. Application rules are processed after network rules. Question 36. An incident responder opens effective security rules for app01-nic. Which set of rule sources is included in the documented aggregation for that interface? Select one answer. Choice A, the NIC NSG, an NSG on a peered virtual network, and the subnet route table. Choice B, the NIC NSG, the subnet NSG, and user-defined routes applied to the subnet. Choice C, the subnet NSG, Azure Firewall policy rules, and application security group memberships. Choice D, the NIC NSG, the subnet NSG, and applicable Azure Virtual Network Manager admin rules. Lock in your answer. The correct answer is D, the NIC NSG, the subnet NSG, and applicable Azure Virtual Network Manager admin rules. For a target network interface, effective security rules aggregates rules from an NSG associated with that interface, rules from an NSG associated with its subnet, and applicable Azure Virtual Network Manager admin rules. You have completed all 36 questions in SC-500 practice questions, Azure Network Security. Review the distinctions you missed, especially network security groups, security admin rules, Azure Firewall, private endpoints, virtual network connectivity, and diagnostics. Thanks for practicing with Web Lizard Lab's CertLab.